but unfortunately we need this room for these presentations. Today we're privileged to recognize the outstanding careers of two of our professors. Dr. Chenyang will be installed as the Fullgraf Professor of Engineering. Dr. Lan Yang will be installed as the Edward H. Florence G. Skinner Professor of Engineering. Professor Liu and Professor Yang, welcome you both, and to your family and to your friends. Welcome. It's a very unique ceremony today, not only because we're installing two, but they're husband and wife, they're married. And I think this is probably the first, Mark. I hope not the last, but it does represent the careers of both Chenyang and Lan coming together at this particular time in both of their careers. And it's a very special occasion. It's a kind of occasion of these installations that are very special for us. You'll hear from Chancellor Mark Wrighton in just a few minutes about the backgrounds of the Charles M. Fullgraf and Edward H. and Florence G. Skinner professorships. But I want to say a few words about Mark Wrighton, our Chancellor. He came in 1995. Mark has made a tremendous footprint on this university in terms of its recognition worldwide, a great international reputation. Undergraduate admissions have doubled. We have a select group of undergraduates coming. The number of buildings that have been built and are to be built and in a process of being built reflect not only his commitment to the building of this university, but also to the strength of how we have grown in the last 20 years since he's been here. So it's a great pleasure for me to introduce Chancellor Wrighton now, who will say a few words about the professorships that we're representing today. Mark?
Good afternoon. It really is a pleasure to be here. As Ralph has noted, this is special for a lot of reasons. First, to our new endowed shareholders. You know that this is the highest degree of recognition that we extend to our faculty. Recognition with appointment to a named endowed professorship is extremely important, obviously, in the life of a faculty member. And we award this recognition on the basis of achievement. Achievement in original research, achievement in our educational mission, and at the same time, we make appointment to people who we feel also have very high potential. And so I want you to know that our expectation is even greater than before. So no rest for the weary, but we know that you love your work, and your work is very important, and we're looking forward to all that you will do in the future. I'm especially grateful that people have traveled a great distance to take part in our program this afternoon from China and from New York and Tennessee, and of course people here in the community. Ralph, I want to thank you for your leadership in nurturing the careers of these outstanding members of our faculty, and I certainly will value the opportunity to see the fulfillment of an additional measure of potential. I won't see it all, I'm sure, but we're fortunate to have these talented people with us as leading members of our faculty. Support for endowed professorships at Washington University is very, very important. When I joined Washington University in 1995, as was noted by Ralph, I felt that we were a little underrepresented with respect to the number of endowed professorships, and my colleagues and I resolved that we would strengthen our support for faculty, enabling us to attract and retain the very best. And in connection with our fundraising efforts, we've secured commitments of more than 230 new endowed professorships during my tenure as chancellor. And that is a record that I think is unrivaled by any other academic institution in the United States. We're grateful to all in our alumni and development team for encouraging support in this form. After all, a great university is defined by its faculty and by its students. And in engineering, under the leadership that Ralph has extended over these last 5 years, the school has developed great momentum, both in recruiting really outstanding students, competitive with the best anywhere, and that includes high name recognition, high quality institutions on both the East and the West Coast, and we have recruited truly outstanding faculty. So our combination of strength in faculty and students is beginning to set us apart from other great institutions. It's a pleasure today to commemorate the Fullgraf Professorship. This was established by a gift from a very distinguished alumnus, Charles M. Fullgraf, and his wife, Charlotte. The gift came actually in our last fundraising campaign in 2004. Mr. Fullgraf's career with Procter & Gamble as an engineer, researcher, division manager, group vice president, and director corresponded with the company's growth from a soap manufacturer to a giant diversified multinational corporation. After earning a bachelor's degree in chemical engineering here in 1939, Mr. Fullgraf joined Procter & Gamble and worked in munitions production during World War II. In the 1950s, he became involved in the dental research that produced the first fluoride toothpaste, that's known as Crest. In the 1960s, he moved from engineering into management, overseeing international operations in England before returning to the company's home offices in Cincinnati, Ohio. There he was director of Asian and Latin American operations. He was named a vice president of Procter & Gamble in 1966 and elected a director in 1974 and retired as a group vice president in 1982. Mr. Fullgraf passed away in 2010. Mr. Fullgraf was among 5 recipients of the School of Engineering and Applied Science first Alumni Achievement Awards program in 1975. He served as vice chair of the Alumni Board of Governors from 1974 to 76. He also served on the Commission on the Future of Washington University. In 1981, the university presented him with its Distinguished Alumni Award. We're fortunate to have Charlie and Charlotte's family here tonight, their son Chuck, their daughter Jan, along with granddaughter and Washington University alumna Hannah, and their grandson Doug, who is currently enrolled in the John M. Olin School of Business in our MBA program. I'd like to ask the Fullgraf family members who are here to please stand and receive our gratitude and thanks for making the effort and participating with us. Now let me say a few words about the other professorship, the Skinner Professorship. This professorship was established with a gift from Florence Skinner Farrow in memory of her parents, Dr. Edward H. and Mrs. Florence G. Skinner. Mrs. Farrow's mother, Florence Garrell Shade Skinner, graduated from the university in 1902 with a degree in civil engineering. At the time, she was said to be the only woman civil engineer in all of St. Louis. She married Dr. Edward Skinner, whom she had met at Washington University later that same year. She died in 1906 at the early age of 24. Mrs. Farrow's father, Dr. Edward Holman Skinner, attended Washington University and received a medical degree from St. Louis University in 1904. A prominent physician in the Kansas City area, he helped found the Kansas City Southwest Clinical Society in 1923 and served as its first president. Active in several radiological associations, imagine radiology in 1923, Dr. Skinner was a diplomat of the American Board of Radiology and served as its president in 1946. He passed away in 1953. Mrs. Farrow received a scholarship to Washington University after graduating as valedictorian from Central High School. She received her Bachelor of Arts in English with highest honors in 1929, followed by a master's degree 1 year later. A generous benefactor of the arts, opera, Philharmonic, and higher education in St. Louis, she was a special friend of Washington University and our School of Engineering. In addition to establishing this professorship, she endowed the Joseph H. and Florence S. Farrow Professorship in Biomedical Engineering and the Florence Skinner Farrow Scholarships. In recognition of her outstanding support, Mrs. Farrow received the School of Engineering's Dean's Medal in 1997. She passed away in 1999 at the age of 93. We're grateful to Mrs. Farrow for leaving a wonderful legacy, professorships, and this one, the Edward H. and Florence G. Skinner Professorship. We're grateful for their wonderful support, and Professor Yang, we're looking forward to your installation as the holder of this professorship. At this time, let me turn the podium back to Ralph Petrano. He's going to introduce our honorees, and we will formally install them as holders of these endowed professorships. Thank you.
Thank you, Mark. I'm honored to provide this synopsis of Professor Liu's career within the Department of Computer Science and Engineering at Washington University. The CSE department trains future educators, researchers in a wide variety of computer science and computer engineering topics. And we recognize the tremendous growth that computer science has had in the world, but also here at Washington University. It is a rapidly growing department. It has really increased the number of undergraduates taking computer science courses, and it's really due to the faculty and the new faculty that we've recruited in the last 5 years that really has made this one of our most outstanding departments. Professor Liu joined Washington University in 2002 after receiving a PhD from the University of Virginia in 2001, master's from the Chinese Academy of Sciences in 1997, and a bachelor's degree from the University of Science and Technology in China in 1995, all in computer science. In addition to teaching on our faculty in computer science and engineering, Professor Liu is director of our Cyber Physical Systems Laboratory, editor-in-chief of the Association of Computer Machinery Transactions on Sensor Networks, which we'll talk about today, and associate editor of Real-Time Systems. He has also served as program chair of IEEE, Real-Time Systems Symposium, an ACM IEEE International Conference on Cyber Physical Systems, an Association of Computing Machinery Conference on Embedded Network Sensor Systems. Professor Liu has made pioneering contributions to the field of wireless health by developing and piloting one of the world's first large-scale clinical monitoring systems that collects real-time vital signs from patients using wireless sensor networks. Professor Liu is working towards the vision of wireless health, where the convergence of wireless sensors, mobile computing, data mining, and electronic medical records will lead to enhanced quality of care for patients in hospitals as well as for outpatients. It gives me great pleasure to introduce Professor Liu. Chenyang.
So our tradition for nearly 20 years is that upon installation to an endowed professorship, we present the chair holder a medallion, and on the face is the seal of the university, and engraved the Fullgraf Professorship, and on the reverse, Chenyang Liu, PhD, March 16, 2015. Professor Liu, it's a pleasure to recognize you now formally as the holder of the Fullgraf Professorship. Congratulations. So we have a memento for the family as well, and Ralph and I will give to Jan and Chuck a replica of the medallion framed for exhibit, and we're very grateful to all of you for joining us this afternoon on this very special occasion. The inscription on the little plaque says, "The Fullgraf Professorship honoring Charles and Charlotte Fullgraf, presented at the installation of Chenyang Lu, PhD, March 16, 2015. Thank you very much.
Thank you.
Okay, Chenyang, the podium's yours.
Okay. So thanks, Mark and Ralph, for the very kind remark. And ever since I joined Washington University in 2002, I'm always very impressed by Chancellor Wrighton's vision and endeavor to position Washington University among the world's best institutions in the world. And the university has benefited greatly from Mark's leadership. And Ralph exceeded all my expectations of, as Dean of Engineering, even though he is a biologist in training. But everything is connected. I agree with Ralph on everything about research, how he emphasized excellence in research as the most important thing of a school, how he values real impact of research, right, instead of counting papers. And every time I need help from our dean, right, so I always get the most enthusiastic response than I ever expected. So thanks, Mark and Ralph, for your great leadership for the university. And we gather here, right, of course, to honor Dr. Charles Fullgraf, right, whose generous gift made this endowed chair happen. I never got the fortune to meet Mr. Fullgraf in person, but I came to learn that he is a distinguished alumnus and a successful executive at P&G. And as a researcher, most impressively, I learned that he's on the team that invented the world's first fluoride toothpaste. So, as a researcher, that's what we aspire to, right? Inventing something that's generate that kind of broad impact on the world's population. I was told the endowed professorship installation is a time where you're supposed to share your baby pictures. So here we go. My grandparents thought I was going to become a diplomat based on the diplomatic smile, right, on this baby. So this is when I was in elementary school. Something happened in the elementary school that I remember. So, this is a typical drill where the teachers ask the boys and girls, what do you want to become, right, when you grow up? Right? So my answer was somewhat shocking in that period of China because I said I want to be a PhD. This is shocking because back then, that was in the early 1980s, China didn't even have a PhD program. I knew about the word PhD because of my role model. So this is my uncle, Dr. Xiaohan Liu. So he actually received a PhD back then. He was one of the first, among that generation, received a PhD in geology in France. And he led the expedition team to Antarctica 6 times, right? It's my role model with great achievement in the country. So, but on the other hand, that incident did also indicate my naiveness as a boy, right? Because ironically, nowadays, I keep telling every of my PhD students, PhD is not the goal, right? So it's only the means that lead to a great research career. This is a photo that we took with my family, my parents and my brother, before I head out to the US. And my parents put tremendous emphasis on education, how you have to get into the best school, how do you have to score the best in your class. And, but most importantly, they taught me you have to aim high in your life. You should aspire to become one of the world's world-class scientists. So here we go. So every time I accomplished anything, that no matter how small, it seems my parents is always a lot more excited than I do. So I thank them for their installation of this of the sense of aspiration in me. And I'm thrilled that I can bring them happiness for just doing my job. Education. So I went to school, high school, to Shandong Normal University's high school. So this was the group photo. I was amazed that my girls can actually recognize me out of these photos. So then I went on, as Ralph said, to University of Science and Technology of China. This is one of the top schools in science and technology in China. And there are two really good things that happened in this school. Number one, it was pretty rare back then in China. It gave me a pretty comprehensive training because I was in this special class for the gifted young. So where I not only got trained in computer science, we also got trained really hard on physics, math, and a range of other disciplines. A lot of all-nighters that you have to pull, but we made it. So the second good thing is I get to hang out with some of the brightest students in China. One of them is being here, came all the way from China. And there was a great miss there too, because I actually missed my wife Lan there. So Lan actually joined exactly the same program 2 years after me. I seem to never caught her or talk to her. We have to wait another 15 years before I finally met her again here at Washington University and start dating and get married. But it worked out. Then I got my master's degree from the Institute of Software at Chinese Academy of Sciences, and then then it's your turn to apply to PhD programs in America, that as is pretty routine from students from USTC. So that's when I applied to University of Virginia, because one of my uncles, who's in the photo, along with my advisor, Jack Stankowick, who is here. So, and this is on my PhD graduation ceremony. So my uncle actually proudly got a PhD from Virginia in electrical engineering. So he told me, I'm not sure you're going to get in, but Virginia is a good school. So I applied, and the department took me. That turns out to be a great decision, for a different reason, because of Professor Jack Stankowick. So it was my good luck that Jack just moved as a renowned computer scientist, just moved from UMass to UVA 7 months before I joined. And I learned a great deal from Jack. Everything from how to do research down to what are the names of different types of pasta. Because, what do I know about Italian food as a, Chinese boy coming from Hefei, China. So, but, now that is a point of reflection. I did sit down and think about, what I've learned, what are the important things I learned from Jack. And Jack can correct me if I'm wrong. But certainly the first and foremost is the courage to explore new areas. And regardless how little you know about it, that's how Jack led us into sensor networks, and later that area became Internet of Things, Despite the fact, we knew nothing about, but fairly, nobody in the world back then knew anything about sensor networks anyway. So we were fortunate to get there first, and it's all because the courage to explore completely open new areas. I remember this incident where, I don't know if Jack still remembers, but Jack wanted me to build some system to do systems research, meaning building real things. So I told Jack straight in his face, that I don't want to build systems, right? I want to do theoretical stuff because theory is research, right? So, well, how Jack has changed me, right? Now everybody knows that I'm a systems person in heart, right? Have to find the excitement in building real things in order to impact the real world. My doctoral students heard this a lot, right? They can attest to it. Write crisply. It's something that I learned greatly from Jack. It's about go straight and make your point, right, clearly, right? Don't, go in circles and, go around your point, right? That benefited my career greatly, right, when you write proposals and papers. One of the most important things that I learned from Jack that I try to model after in my own lab is students are the most important thing in a lab. Right? A research lab is not just about inventing new technologies and science, but also to train and mentor students into world-class scientists. For that, I'm grateful. And so, in the end, right, so fortunately, in the end of my PhD, so that's about when the sensor net area started, and Jack led us in, there goes the golden age of Internet of Things start. And that's when I joined Washington University in 2002. Not being a native English speaker, I actually checked out exactly what golden age mean, right? Just make sure I put the right title in the announcement. So I did. So in Wikipedia, it says the golden age means a period of time in a field of endeavor where great tasks are accomplished. How appropriate. So that's it, right? So the golden age of Internet of Things came about with the convergence of three fundamental major technology trends. First is in hardware, where people figured out ways to build small embedded computing devices that integrate computers, sensors, and radios in small packages. And the second major technology trend happens with regard to low-power wireless networks, right, and the protocols that can connect millions of devices into the internet. And finally, the field of data analytics, right, that allow us to make sense out of large volumes of data, right? For a systems researcher in heart now, so there's nothing more exciting and more fun because these trends enable us to start building large networked systems for smart sensing and control. So these are just some examples of the gadgets that we play with in our research. Right? This is a computer that monitors vibrations with high fidelity that was developed at UIUC by our collaborators that we in turn use to build these systems to monitor structural health and control them in our civil infrastructure such as buildings and bridges. This is the Shimmer device that we are collaborating with Susie in medical school to analyze the motion and fall risks among the elderly population, an increasingly important topic in this aging population. And finally, this is the wireless pulse oximeter that we built in order to monitor vital signs such as heart rate and oxygenation in this collaboration with Dr. Tom Bailey and others in the medical school. So I'm going to just give a couple of examples that we tried and with great promise in how Internet of Things systems will make us safer and healthier. So this is the thing that Tom and I talked about a few years ago. Right? So there is this big problem of clinical deterioration among patients in general hospital wards. So in fact, 4 to 17% of them suffer adverse events, right, such as cardiac and respiratory arrest. People know for a long time that clinical deterioration is often preceded by changes in vital signs. But unfortunately, we don't measure these vital signs continuously in real time. Right? For many of you might know that nurses usually have to manually do this work once every 5 or 10 hours. So as a result, you wouldn't be able to detect the changing clinical conditions among the patients. So we end up trying to build a new wireless real-time patient monitoring system, right, that instead of measuring the patient's vital signs once every 5 to 10 hours, we measure them once every minute. And then we feed these data wirelessly into centralized databases where they can be analyzed. So what are we doing? Essentially is to provide the same level of monitoring for all patients in the general hospital wards as if they are in the intensive care units. So that goes from about 100 patients in Boston Jewish Hospital to the 1,000 patients, potentially. And we want to build it in a way that's affordable and scalable. So we build this on top of wireless sensor networks technology. So these are large wireless mesh networks that require no infrastructure to build. Right? So this is a wireless pulse oximeter that you saw earlier. And this is the only infrastructure you need, which are these little embedded computers. All you need to do is to plug into the wall outlet. And if we have enough of them, up they go, they form a mesh network. They can stream whatever vital signs from whoever patients you are interested in into the centralized database. So this is low cost and easy to deploy. So Washington University is the special place where you can do this kind of interdisciplinary research and make it real. Right, so this was the first trial that we did with Tom in Boston Jewish Hospital. This is about the first ever clinical monitoring system that was built and piloted in a real hospital using wireless sensor network technology. It lasted 7 months, enrolled 46 patients. It provides real-time monitoring. As I promised, we measure heart rate and oxygenation of every patient once every minute and feed that data into the database. And what's really impressed ourselves and surprised everybody was how reliable these low-power wireless mesh networks are. So in fact, we achieved over 99% of network reliability among all the patients in terms of median value. And that picture shows the high-risk cardiac unit where this was first piloted. And then, once with this feasibility study in hand, so we end up deploying a much larger scale system and scale it up across a large portion of the Boston Jewish Hospital that spans 7 different hospital wards with a clinical trial over 14 months, enrolled about 97 patients. And furthermore, right, this is a system that's fully integrated with the hospital IT infrastructure that include feeding real-time sensor data into the electronic medical record database systems. So this is important, right, because then you can conduct data mining algorithms where it can analyze high-risk patients and issue advanced warnings to the nursing staff in the hospital. And this is the area where my colleague, Dr. Yixin Chen, and Dr. Marion Coliff, Dr. Tom Bailey, and are working on, right, with great promise. My second example, right, of how Internet of Things make us safer is about structural health monitoring. Right, health monitoring are different kind of things, which are our aging, civil infrastructure. So I don't know how many of you know, right? Our civil infrastructure is actually in great trouble. Most of our highways and bridges were built back around 1950s and 1960s. That combined with a design lifetime of about 50 years, you do the math. Right? So in fact, right, so the American Society of Civil Engineers estimated that over 26% of the nation's bridges are structurally deficient or functionally obsolete. So that picture, right, that shows a few months ago where a bridge in the Washington state, right, collapsed into the water. So I was actually interviewed by IEEE Spectrum for that, right, how you must build smart bridges that can detect these damages on the fly. So because of these natural disasters, these disasters that happened, there's actually a rule that says you have to manually inspect these bridges, but unfortunately once every 2 years. right? Because it's so labor intensive and expensive to do such inspections. So our vision is to build a wireless sensor network that can automatically detect damages and even localize them, right? Instead of inspecting these structures once every 2 years, you can now inspect them every day. You can inspect them every week. Or you can inspect them on demand, right, during and after a disaster. That is very important, right, whenever a minor earthquake hits a big city, right? And these are easy to deploy systems for very long-term monitoring. We not only want to monitor such structures, we also want to save them during those disasters, right? This is wireless structural control systems that we designed, right, together with our colleagues at Shirley Dyke at Purdue University in civil engineering. So this is a case study we actually did. Right? This is the Bill Emerson Memorial Bridge. It's a very large bridge, important one, carrying 14,000 vehicles across Mississippi every day. It's also a very vulnerable part of our infrastructure. It's located in the New Madrid seismic zone, right, which is with earthquake probabilities. So we challenged ourselves in trying to design an actual structural control system for the bridge by replacing joints of the bridge by 24 hydraulic actuators. We figured out how to design an Internet of Things system, and specifically a wireless control system, by carefully co-designing the control algorithms and the wireless network so that you can do this kind of real-time control in an effective way. And one downside of doing this kind of research is really hard to run experiments. So to do that, we actually built this entire so-called cyber-physical simulators that integrate these high-fidelity bridge models along with realistic wireless network simulations. Right? So these are examples that we did. Right? Of course, I'm the one here giving the talk, as always, but the real heroes of the cyber-physical systems laboratories are the students, right, who did all the work. A few weeks ago, there was a prospective PhD student coming, and I talked to him, and he asked me, what type of student do you want? Right? I quibbled that, oh, we want perfect student. Right? But then I realized that's probably a mistake, right? So I added, right, with some real thought, right? But most importantly, we really want ambitious, idealistic students. Right, who put their heart and soul in creating technologies that make a real impact. Right? So indeed, I was fortunate to have all these students who believe in that philosophy, working hard every day, trying to make that happen. So it's extremely satisfying to see them go on to lead successful academic careers, as well as important industry R&D positions. The modern science and engineering, and particularly Internet of Things, is about collaboration. Right? So it's never a single person's accomplishment. And oftentimes these collaborations cross boundaries of departments, of disciplines, of physical universities, of continents, right? And industry and academia. So I was extremely fortunate to have wonderful collaborators, not only from computer science and engineering, but also other departments in engineering, but also friends at the medical school, but also many other universities, as well as important industry collaborators. For that, I'm grateful. I should thank my computer science colleagues for creating a warm academic home. The Department of Computer Science and Engineering has always been a good place to work for. Dr. Kathleen Roman is the chair, right, who hired me and was instrumental in growing my academic career. John Turner is always someone I looked up to as a world leader in computer networking research. Jeremy provided the steady hand as we go through a transition phase in the department. Now I'm thrilled to have Rock Gurin as our new department chair, who is doing a great job leading the department forward. I thank the colleagues, all the faculty and the wonderful staff members who make our life so much easier and happier. Thanks for energetic, collegial, and supportive environment. You cannot ask for a better environment than the CSE department, where you can happily just do your scientific research. Now that my girls, two of my girls are now asleep, right? Sophia, as always, the good big sister, is still there, right? So nothing brightened my heart more than you come home with these little girls climbing all over you as if you are a big tree or you are the big bear. And people often ask Lan and me, right, how did you handle it, right, with 2 professors and with 3 little children at home? There are 3 answers to it, right? The first, these are just perfect angels, right? They have the beautiful smiles that melt your heart. And come on, Sophia even has a real wings in this picture, which, by the way, Sophia actually made herself using our cell phone. And secondly, I thank the grandparents, Lan's parents, right, who was tremendous help in taking care of these children, right? And third, so we thank the wonderful teachers at the WashU Nursery School and the full-size school for all the love and education that turns them into such wonderful kids and students. And finally, and the most importantly, right, so I finally caught Lan at WashU, right? So that's just fate, right? After missing her for 15 minutes and 15 years, it was just fate that the day in January 2007, when she joined from Caltech, that was the day when my life was changed forever. To give you a small example how my life has changed, when one of my early students, Dr. and Professor Lan Yang, who now does some wonderful work at Michigan State, when his departing speech, right, he made this comment and advice to other students in the department: don't ever argue with Dr. Wu. Right, I didn't know, right, he meant I'm just a strong debater, or I actually don't listen, right? But that all changed ever since Lan arrived, right? So I could never win a single argument with Lan, right? That shows, having a star scientist as your spouse sharpens your analytical skills and also train you to listen better. But Lan is so much more than just a scientist spouse, right? She is absolutely the better one among the 2 who are being endowed today, brought all this love and care to our happy family. There's no better person I want to share this moment with. And I also thank every one of you who come here and join the celebration. Thanks.
Thank you, Chenyang. I'm now going to turn the podium over to Ari Nahori, the Chair of Electrical and Systems Engineering, who will introduce Lan. Ari?
Good evening. As you just heard, I'm Ari Nahori. I chair the Department of Electrical and Systems Engineering at Washington University. I'm honored to be here celebrating this double professorship event. The Department of Electrical and Systems Engineering is dedicated to advancing the frontiers of sensing, imaging, telecommunications, control, security, and sustainable energy. It is one of the oldest electrical engineering departments in the country. Our faculty and students are dedicated to high-quality, interdisciplinary, revolutionary education and research. With 300 undergraduate students, 135 master students, and 50 doctoral students. We strive to enhance education by providing modern curriculum, renovated laboratories, and hands-on research projects. As many of you know, our department has more than tripled the number of undergraduate students in just 4 years, and this is thanks to the efforts by our faculty who made tremendous effort to make this happen. In fact, last spring, in spring 2014, our department had the maximum number of degrees awarded among the different departments in our school. This is a very different situation than just 4 or 5 years ago. Professor Yang joined the Department of Electrical and Systems Engineering in 2007 as assistant professor after earning the PhD in applied physics from Caltech in 2005. She leads the Micro-Nanophotonics Laboratory in the School of Engineering and Applied Science. Professor Yang's research interests are fabrication, characterization, and fundamental understanding of advanced nano-microphotonic devices with outstanding photonic properties. Currently, her group focuses on silicon chip-based ultra-high quality micro-resonators and micro-lasers made from customized spin-on-glass synthesized in her lab. Her group demonstrated the first on-chip micro-resonator-based particle sensors that can not only detect, but they can also measure single particles one by one. These are nanoparticles, to be correct. In addition to nanoscale sensing, her research includes investigation and development of novel photonic systems with novel functionalities for unconventional control of light flow. Examples are loss engineering to control a lacing system and non-reciprocal light transmissions. In a parity time symmetric optical resonator system, an all-optical analog of an electronic diode that allows current flow in one direction. Professor Yang published papers in top journals, including Science and Nature. She received many awards. In 2010, Professor Yang earned the National Science Foundation Career Award, and in 2011, she was honored by President Barack Obama with a Presidential Early Career Award for scientists and engineers. The Early Career Award is the highest honor bestowed by the United States government on science and engineering professionals in the early stages of their independent research career. I wish to add a few personal comments about Lan. Lan Yang was the first faculty candidate to whom I gave an offer, and she became the first faculty member that came to the department after that offer, since I became chair in 2006. When we interviewed Lan, we were of course impressed by her work, but not less so by her excitement and enthusiasm. This was quite amazing to see, and this has continued to this day. Lan also showed a lot of self-confidence as she knew she would start a new research area in the Department of Electrical and Systems Engineering. Having Lan as the first hired faculty member helped us rejuvenate and hire other strong faculty members since 2006. Lan is also a very gifted teacher, loved by all the students. She continued to amaze us by her achievements. Sometimes I felt that I get confused when I get another achievement by her. Is it the same one that I got several hours ago, or is it a new one? And I had to check very carefully, because very often they were different. So it is wonderful to be able to recognize Professor Lan Yang for all her achievements at this special event. It is my pleasure to invite Dean Kotranov back to the podium.
Now, Lan, Mark.
As well. Please face the audience. If you have a PhD from Caltech, you'll do well at Washington University.
Thank you.
We're very grateful to you for all the great things that you're doing. We have a medallion for you as well, very similar, and inscribed the Edward H. and Florence G. Skinner Professorship, and on the reverse, Lan Yang, PhD, 15th. Congratulations on the appointment.
Thank you. Thanks a lot. Thank you. Thank you. Thanks a lot. Okay, so here's my turn. Chenyang said it's great to be the first one, so they can take a break and relax and enjoy my talk. But you know, I want to tell you in advance, I'm not as good a speaker as Chenyang, so bear me for 15 minutes. So here's my talk. As you can see, I want to take that opportunity to introduce my work to you. It's about trapping light in whispering gallery structure. I hope I can explain that in more details later. Before I talk about that, I will say everything happens for a reason. For example, like the Skinner Professorship, it's a legacy left by a generous family that is shown here. So in Mrs. Florence Skinner Farrows, she established this Skinner Professorship in memory of her parents, Mrs. Florence Skinner and Dr. Edward Skinner. And when I read the story, I can't help thinking that how great it is to give things to others. Thinking about this, many times in nature we think taking is better than giving. But however, in reality, you might find out many examples showing that actually giving is better than taking. This is a perfect example, a legacy left by a family. The family supported the university by setting up a fund, and the legacy was remembered by us, and we pass this legacy from one generation to another one. And surely I will extend their devotion and love for education and the students. As the previous Skinner professor, that is Dr. Skinner, Dr. Chris Byrne has done. He was a former engineer of engineers at WashU, the dean of engineering school at WashU, and he's world-renowned scientist in automatic control. And follow his footsteps to do more things and make a contribution to the community. And I also want to take the opportunity to show my appreciation to the Chancellor, Mark Wrighton, for what he has done for us. And he has a wonderful leadership and vision for the school to make WashU a wonderful community. And for people like us who are in the system, we benefit a lot for being here. And also, the other person I want to show appreciation is Dean Ralph Codrano. As a Chenyan, we share a lot of I share a lot of comments with Chenyang about Ralph. To be honest, in addition to his outstanding leadership and vision that guiding engineering school, he is not only a dean in my eyes, he is a wonderful and outstanding researcher, share his personal experience as a scientist. Actually, I think he has a lot of influence on me, although he is in art and science biologist, I'm an engineer. However, he really shaped my view for career development and learned a lot from him. And Rob is a person who makes our engineering school a unique place, not only for well-established researcher, but also for myself a few years ago, who grew from early-stage investigator to a more mature person. And I can't express how thankful I am for him. And as Chenyang said, we need to show the baby photos. I said I did that. And I'm sorry, so give a guess who I am. I bet most of you might make the wrong answer because Sophia did the wrong answer. He said, this is me, I'm sorry. I'm the one who looks like a boy in the photo. But don't blame me. If you look at my father's hairstyle, you know where it comes from. So you know, that's the downside of being baby. You know, you have no control, you cannot express opinion, and you have to follow other people's taste of beauty. Yeah. So different from Chenyang, who has his personal goal when he's young, he wants to be a PhD. I have no idea what is PhD. Growing up in a town with a population of 70,000, most people there just have diploma degree, at most diploma, high school diploma. And my father is one of the very few who got a college degree. So I have no idea what at most a college degree for me. So it's really beyond my parents' expectation. I will get a PhD in a nation where people speak a different language. My parents don't understand and don't know how to speak. And also, it's also beyond the expectation. I will become a professor who give lectures in English every week. So it's a surprise. So let me share some personal experience with you. I think this it's not bad to show some personal experience because it will tell you, give some clues of what leads me to my current positions. And for me, I think life is like a journey, experience different opportunities with different views, and sometimes we need to make decisions at a cross-section of the roads. And here it comes. My life is not as smooth as Chenyang's. You can see that. The elementary school is straightforward and nothing happens. And however, after middle school, I need to make a decision between a high school and professional school. Because at that time, there is still stereotype comments about girls. People normally think a girl is not girls not as good as boys who are very good at math and physics. And in high school, they emphasize a lot about math and physics. My mother was really concerned. She was so concerned that I couldn't find a job if I go to high school. So they don't want me to make this choice. And it's very fortunate, the former principal of this local high school, he gave me admission letters, although I didn't apply it at all because I was forced to apply for the professional school. But he just gave me the offer letters and successfully convinced my parents to choose this one for me. So happily, I take this journey and experienced 3 years of excitement in the high school. And fortunately, I didn't disappoint my parents. I was very good at math and physics. I was like #1 in math and physics exam all the time. When I went back last year, during my sabbatical to my local high school, the teachers still remember me. He said, "You're just really good. Out of all the students, as a girl, you're very good on those you're like models I showed to other students." I'm really happy to hear that. So after 3 years of training in high school, again, I was facing the choice. I need to think between the special school and others. Why I call it special school? It is University of Science and Technology of China. This is a top university in China that is famous for rigorous training in science. At the time, I need to plan why I need to make a choice because education system in China is different from that in US. You cannot apply as many schools as you want. Instead, there is application form. You can only put a limited number of universities there. And also, because at that time, there's no internet, which makes recruiting very difficult. You can put, for example, 5 schools there. But however, if you couldn't make the first choice, it's very likely you might end up nowhere because, if the first choice didn't choose you, the portfolio is still physically with them. It's very difficult to transfer them to the second choice. And by the time your portfolio was transferred to the second choice, they already made all the decisions for the students. So you might end up nowhere. And let me tell you the fact. In my high school, historically, there is only one student in 50 years that is admitted to this school because it's really too good. And I grew up in a small town. And if history is our guide, then it's a stupid decision to apply for this school, right? So sometimes I do think most of the time we need to follow history, but sometimes you do need to make a break and to do something different. And so I totally understand my mother's concern. If I choose this as my first choice, I might end up nowhere. Unfortunately, I need to mention again the former principal of this high school. Again, it's him. This gentleman has been keeping an eye on me because I was special for him. So he successfully and magically convinced my parents I should choose USDC as maybe that's a risk. I don't know how to make him make the decision. Anyway, he convinced my father and my mothers, And we put USTC, University of Science and Technology of China, as my first choice. And again, luck is on my side. I got admission at, historically, I was second student who was in my town and who was admitted to the school. So there's a huge celebration actually for that news. I was even interviewed by this local TV station for what happens. You can see it's really big deal. And still nowadays, I told Ralph and Arya, I was like a model kid in my hometown. I went back last year, they still do interview with me because they said, you're just like a role model, showing those kind of things and show how the motivation to study and how education can lead you to a wonderful position. And once you're in, I was in STC, then things are straightforward. As Chenyang mentioned, I was in a special program. So I was in a special program, so a lot of trainings, and naturally I just followed the footsteps of senior students. Maybe Chenyang is one of those senior students, and I applied for PhD program in the United States, and fortunately I got offer from Caltech. And I got offer on my birthday. I think maybe superstitious, that is my destiny. So I went there, and it's very nice because there is another great person waiting for me there. That is Professor Kerry Valhalla. He is a faculty in applied physics department. When I found him, at that time I got a 4-year fellowship from Caltech, which gave me freedom to choose the faculty I can work with and approach him. I told him my background is in material science and solid state physics. I know nothing about optics, but I think this is fascinating for me. I don't know why, maybe as he might think the same as Arya has done. He might have saw my enthusiasm and saw my motivation to learn new things. He took me, and he's the one that really guided me into this fascinating world of photonics. I learned a lot of things from him. He showed me how to work on a scientific project, and he has great insight on science, and his attitude for research still influences me nowadays. And I truly thank him for all the education and advice I have received from him. And in 2006, I applied for a job, and WashU gave me an offer. And I came here in 2007. It turns out WashU is the right place to start my career. So for that, I wanted to mention an interesting point that is pointed out by a Chinese philosopher 2,000 years ago. And he pointed out, to accomplish a goal, there are 3 factors. This is really important. Let me translate that in English. So 3 factors are right time, in the right place, and with right people. With those, you can do anything. And later on, just a few years later, another Chinese philosopher further clarified this. He said, among the 3 factors, the right time is not as important as the right place, and the right place is not as important as the right people. I totally agree, and I think life is about people and the people you meet, and the kind of things you can do with them. And Dr. Arya Neharai, I cannot say how much I appreciate all the support and help from him. He is very personal and professional. I like that. I really don't, I think in life, you cannot really separate the professional life completely from your personal life. He is a perfect mixture of everything. He supported me whenever I need help, and he is the one who teach me how to go through the hard time and also teach me how to face the difficulty. And I really appreciate that. And I also want to mention that the kind of trust I built with Arya is really important. I think that plays a very important role for the success of my career, and I feel very lucky. And then it makes it more difficult to move around. Actually, there's a joke one day, Chenyang came back and said, "Are you applying for another school?" I said, "No. Where did you have that?" He said, because in one of the meetings for him with a student, the student said, "Dr. Lu, should I change advisor?" And Chenyang said, "Why?" He said, "Because I heard Dr. Yang is moving, and you are moving too, right?" And Chenyang asked me, I said, it's rumors, this spreads around. But I told him, you know what? With such a wonderful school, WashU, and the great dean, great chair, it makes it really difficult for me to change, to move. I really cherish everything here. And in addition to the leaders at WashU, I also wanted to thank my colleagues throughout the years, all the support, all the patience with me. I feel like I'm a spoiled kid in the department. Although I'm a senior, I'm not used to being a senior now, because really I was supported by the senior faculty, and I really appreciate all those help from them. And of course, I wouldn't forget to thank my wonderful staff, because they are the one who make my life much easier. They help to deal with paperwork and routine things, and many times they tolerate my late response, and I really appreciate all those. And in addition to the colleague in my department, I also wanted to thank all the friends and collaborators I found at WashU. They are the greatest. I appreciate all the collaboration, the friendship, and the support whenever I need from them. And they do make WashU a more attractive place for me to live and to stay. Okay, so back to my research. Originally I was thinking of making this talk all personal, and then Chenyang said, you cannot do that because this is endowment ceremony. You need to convince others. There's a reason that you're here. So of course, then I should talk about research. So here it comes. And I'm really proud of what I'm doing. This is a fascinating device that is smaller than the human hair. Although it's tiny, but it can do big things. You can functionalize the device so that it can be turned into a laser for communication, and it can be turned into a sensor to capture virus, aerosol particles, and even also can capture small molecules from the gas. And also, by manipulating the structure, it can be used for harvesting sunlight for solar applications. It can also be assembled together to make a compound structures that can control the light flow as you wish. Okay, however, because of limited time, I couldn't talk all of them, so I focused on one application, that is build an optical sensor using such a structure. This structure had a unique feature. Before I talk about that, because I'm talking about nano sensing, so I need to tell you what is definition of nanometers. This is a length scale showing that a nanometers is over 1 million times smaller than human hairs. So it's really tiny. So, and if you wanted to use nanometers as a unit to evaluate and measure objects, then this tennis ball is over 1 million times larger than the nanometers. So as you can imagine, it is impossible for human being to see a structure in nanoscale. So what should we do? Think about the fact the nanoparticles has become ubiquitous in our everyday life. It has been used in some blocks, and it has been used for medical imaging. It has been used in materials to modify the material structure so that it becomes stronger and stiffer, and also increase the lifetime of the materials. And it's also used in batteries to improve the performance, everything. And also, there's a downside about nanoparticle. Some disease, such as asthma, is associated with ultrafine particle in air. So think about that. It would be great if you can invent some portable device you can carry on that allow you to detect and measure particle. That'd be great. Among all the features, we care about the size, because the size of a nanoparticle affects a lot of properties associated with nanoparticle, such as toxicity, solubility, and light emission properties. There's many things that we care about associated with nanoparticles. Okay, what is solution? Here comes the solution. I bet some of you might have been into this kind of cathedral dome before, right? Over 100 years ago, a scientist have noticed in such a structure, cathedral dome with circular boundary, a single whisper can be heard throughout the gallery spaces. That is why it is called a whispering gallery. And think about this concept. It can be used in optic domain. A light wave can circulate around the circular boundary as the sound wave do in this cathedral dome. So thinking about this making a structure with circular boundary, then you can support an whispering gallery optic modes. So what is modes? Modes is a kind of things that it corresponded to different optic paths that can be taken by the lights. Let me show you some videos. Okay, what is mode? because mode is something we can use to evaluate and measure nanoparticles. So thinking about a rabbit jumping from one location to another one, the different routes, right, different paths, and thinking about it similarly in this circular structure, the different paths that can be taken by the light wave. These are real images from our sensors. The size of those are smaller than the human hair. I just enlarged those so you can see that. You can see there's a narrow path and there's some broader path, and this one is the broadest one compared to this one. A different path, physical path, can be taken by the light. That is modes what I'm talking about. And this is a movie showing that how we excite different modes. Different modes means different patterns, different paths in the structures. So the structure itself is smaller than human hair. And you can see different modes can be excited. And how do we use that to measure nanoparticles? So here is what we routinely measure in the lab. This is what you're seeing. Here, this is a structure fibers that we can use to couple light out of a structure. This is a quantized signal. As you can see, because when the light is trapped in the structure, the energy didn't come out. So you can see a dip, right? Because the energy is saved here, it didn't pass through. So these dips give you information of modes in the structure. We notice once there's a nanoparticle, which can be molecule, virus, or aerosol particles landing on the Western gallery structures, then the single resonance modes will split into two. And this is separate modes. That means that nanoparticle open a different channel, start a new path, optic path for the initial light. So this new mode is result of the nanoparticles. So it's understandable by analyzing the new modes, we can trace back the information of nanoparticles. So this is a quantized signal. It shows experiments in which we deposit nanoparticles one by one on the structure. So one dip split into two, and further changes whenever you have new particles. It's like the way we recognize people. We can differentiate different peoples because they look different, right? For those, as you can see, although it looks quite simple, just two dips, but it's sophisticated enough for us to get information about the nanoparticles, which is reason to trigger the changes in the patterns. So that is philosophy that we use to do sensing. So initially, you have such a tiny circular structures, and light was trapped inside. They find their own path. And once a nanoparticle landing on the structure, they open a new way, which means a new optic mode excited, a new route that can be found by the light, so that it can have new two modes. They appear in different colors. By analyzing the appearance and the location of two modes, you can trace back information of nanoparticle. It's just as simple as it is. Okay, so this work was reported. It is really seminal work. It's the first time that people found out that we can use such a tiny structure to do quantitative measurement of nanoscale structure. So it has been reported in US News, National Science Foundation, and many other medias. And for that single work, I got this Presidential Early Career Award, and I went to the White House, and that is me. And actually, Sophia went to ceremony, but I bet she was kind of bored in the ceremony. And it's kind of interesting. Chenyang noticed that. He said, "You're surely in a good area," because we went to the ceremony, and each one of the recipients went on stage to get the award. And once in a while, he would see the buzzword about photonics. And so sometimes he joked on me. He said, "Okay, maybe that it's mainly because you work on hot area, hot topics." But I would say it's because the wonderful work that we have done. And talk about work, I need to show the photo of our hero. I think, as Chenyang mentioned, I'm here to present the work. I'm the one to get all the honor. However, I really wanted to say that those people are the ones that take me to this place. First is Shaheen Osmer. He is a wonderful person. He is a talented researcher. Not only that, he is a great person to work with. I feel so fortunate to have him in my groups. And also my current students, some of graduate students and some talented undergraduate students. And Yishang actually is a freshman. I was really amazed that all students is so passionate about research. I'm also happy that I have the lab that can provide a venue for those undergraduate students to pursue the passion for research. I also wanted to thank my former students, and those are undergraduate students too. The success of my lab is not separate from the hard work from them. I also appreciate the visitor who has spent some time in my lab. So those are my heroes, and I'm really happy that I have a chance to work with them, as Chancellor Wright pointed out. Now being an endowed professor, the more mission I should fulfill. And with such a wonderful team, I'm really confident we can do more exciting work in the years to come. And in addition to my own group members, I also wanted to thank my collaborators. They are the ones that help to broaden my horizons to do a lot of things beyond the reach of my research groups. And I really appreciate the chance. And of course, there are some other non-professional people I need to thank. The first one are my parents. All these years, they have been standing beside me. No matter who I am, no matter what kind of things I do, they always support me. I really appreciate them. And of course, our little angels. Okay, one of them is just woke up, and she is laughing, seeing her photos right here. And actually, I found the child raising kids is quite interesting, because it lets you know what his bottom line is. You can't get mad when somebody messed up your computers and somebody just wear you out, or somebody do something that drive you crazy. Ultimately, you still love them. I think that teach me, the human relationship actually is just as simple as it is. We just love each other and support each other. It doesn't matter what they do to us. Ultimately, we're in a harmonic situation and happily live ever after, as long as we tolerate each other and give love to each other. And of course, another very most important person I need to bring it up is Dr. Chenyang. He's one that enriched my life and make life a wonderful journey. As I mentioned in the very beginning, I'm not as good a speaker as Chenyang. So here and also it's around the end of this speech, I'm really running out of good words about appreciation. So I want to borrow a line from romantic novels. The title of the book is Notebook. Some of you might have read that. So it said, every day we're together is the greatest day for me. I think that's a quote I give to Chenyang. And in the end, I wanted to thank all of you for coming to the ceremony, because it's such a special moment. I really appreciate you being here and to share the happiness with us. And thanks for your attention.
No questions. It's really been a very happy occasion tonight, and I want to extend again our thanks to all of you coming, but also to two outstanding faculty members here in computer science and also in electrical and systems engineering. So thank you all for coming, and we hope you have a good evening and enjoy the sunset that's out there, I hope, still. Thank you.